Hello grade 10 AP Maths kiddos. Welcome to a second part of simultaneous equations where the concept is exactly the same. So this first slide is merely repeating the same rules I've already given in the previous video about the steps that you need to use to solve simultaneous equations. I know this first slide has plenty words and it seems quite verbose. I'm not even going to bother reading through it. It's just there for you to perhaps jot down if you feel more comfortable with the idea of writing down steps as in what you must do and when. For now, let's jump straight into an example so that you can see it's not so bad after all. Here we are asked to solve for x and y in the following system of equations. Let's compare this example to what we were given last week. Here we have two variables to solve and two equations given, just like last week. If you have if the number of equations given matches the number of variables you are required to solve, then you're A4 away, you know you can definitely find your solutions. Last week's lesson, however, only involved a system of equations of straight lines. So basically everything you were solving for last week, you were solving for the point of intersection of a straight line, of two straight lines. And there is only ever one point of intersection for two straight lines. However, this week we are looking at the points of intersection of a straight line, y equals x minus 1. That is super obvious that that's a straight line. But the second equation is a slightly more obscure. Do you see that if we were to make y the subject of the formula, we'd end up with y equals x squared plus 2x minus 7. Now that is the standard formula for a parabola. I know in grade 10 we haven't yet looked at that exact type of parabola, but you should know that if you have a y equals x squared, if you see an x squared, then you must know we are dealing with a parabola. To be more specific, we're dealing with a smiley face parabola because the coefficient of x squared is an invisible positive 1. So that's the parabola there in blue. Now let's look at the pink equation, y equals x minus 1. That is the equation of a straight line whose gradient is positive. So that function could possibly look like that. We have a parabola and we have a straight line. Now I'm just giving a rough idea. You don't actually have to know what these functions look like in order to solve the simultaneous equations, but it really will strengthen your depth of knowledge and your ability to apply yourself in different scenarios if you can link up the fact that equations are merely functions in algebra, and functions are actually just equations on a picture. Right, so now let's look at these 2 points at which the parabola and the straight line intersect. By solving this system of equations, we are finding the coordinates of those 2 points. For now, I'm just calling it x value 1 and x and y value 1 versus x value 2 and y value 2. I'm also just labeling my equations. I'm calling the pink straight line equation 1, and I'm calling the blue straight line equation 2. Now let's follow the steps given on the first slide. Let's check that from equation 1, is one of the variables the subject of the formula? Yes, it is. Y is already all by itself. So we can take x minus 1 and note that we can replace any y we see elsewhere with x minus 1 instead. So equation 2 has y plus 7 equals x squared plus 2x. So instead of writing y plus 7, we can write x minus 1 plus 7 because that is another outfit for y. That is what y is equal to. And now we have an equation in terms of one variable. So we can solve for that variable. Let's take everything over to the right-hand side of the equation so that we're just left with a 0 on the left. And we'll see that we now have x squared plus 2x. Take away the x, add the 1, and take away the 7 to get a trinomial, which is x squared plus x minus 6. We can factorize this trinomial and solve for x, and you will see that x equals 2 or x equals negative 3. Remember, in advanced maths, we can also solve equations in the complex plane. So if you could not factorize that trinomial, then you try using your quadratic formula, and it's very likely that what's underneath the square root of the quadratic formula ends up being negative, and then your x values end up being non-real numbers, which is perfectly fine because we can work in the complex number system in AP Maths. Now we have x equals 2 or x equals 3. But if you look back to the sketch, that means we only have half of the information. We have an x value at x1 and 1 at x2. I've put the negative 3 at the coordinate on the left because negative 3 is to the left of positive 2 on the x-axis on any number line. Now let's use those x values to solve for their corresponding y values. So you can choose equation 1 or equation 2. It really doesn't matter. I just choose the simpler equation for the sake of easy substitution. So y equals x minus 1. We know that x is possibly 2 or x is negative 3. When x is 2, we can replace the x in x minus 1 with 2 minus 1, and we get a corresponding y value of 1. When x is negative 3, using the same equation number 1, y equals x minus 1, we can replace x with negative 3, and we end up with y equals negative 3 minus 1, which gives us minus 4. And voila, you now have two coordinates that represent the points of intersection of a parabola and a straight line. So if you'd like to write your final answer like the green coordinates given at the bottom right of the screen, you can. Otherwise, if you've just underlined all four answers, 2, negative 3, 1, and negative 4, then you have solved the system of equations. Well done. The next slide will give you 5 more questions for you to tackle on your own, and I will upload the memo for you to check your answers. Good luck and enjoy.